There is something called as dendrogram. This is a tree-like diagram that summarizes the clustering process basically. Yeah, now the distance between record 1 and record 2, the distance between this is given using the distance from here to here. Here on the y-axis you have the distance. Say this is 0, this is 0.5, this is 1, this is 1.5 in that way. That's distance measure. So the distance between 1 and 2 records is given using this distance. The distance between 4 and 5 is given using this distance. Based on this y-axis, you know for a fact that there is least distance between 1 and 2 in comparison to everything. There is least distance between 1 and 2. So you're going to cluster or group these two together. And the next least distance is between 4 and 5. And the distance between 4 and 5 is given using this line there. So these two are part of a cluster. Now you need to find out the distance between this record 3 and this group 4 and 5. So the first thing is you try to find out the distance between different records. That is, you try to find out the distance between 1 and 2, and 4 and 5 records. The second thing is you're trying to find out the distance between the record 3 and this cluster, or a group rather. And the distance between 3 and this group is given using this, from here until here. So now you have two groups, cluster A and cluster B. So you also need to, oh my god, so alright, sorry. The first thing is distance between records. Second thing is distance between each and every record and the group. And the third thing is distance between two groups. Now if you want to find out the distance between cluster A and cluster B, it is given using this distance. Complete distance rather. Yeah. Because on y-axis you have the distance. This is how you calculate, or this is the kind of inference that you want to draw. Now based on your business strategy, you need to decide on how many clusters you want. Too many clusters, probably you do not have the time, energy and money to be invested on drawing strategies for each and every cluster. Too less number of clusters also might not meet your business objective. So if you look at this, this is a cluster dendrogram. If you try to cut it here, then if you hold this with your hand, assume that this is a thread, and if you hold this with a thread, how many clusters do we have? This is one cluster, and this is another cluster. So you try to devise a separate marketing strategy maybe for this cluster, and a separate marketing strategy for this cluster maybe. At the same time, if you try to cut the cluster at, say, this location, how many clusters will you have? A and B forms one cluster. This record 3 is considered as another cluster, and 4 and 5 is one cluster, right? So now you have 3 clusters. This is one cluster, and this happens to be another cluster. This is third cluster. So it always depends on your business strategy. The clustering that you do always depends on the business strategies that you have. All right. Now, so let me erase this first. And let me proceed to the next step. Yep. So this is what it is, right? So first step is you try to find out the distance between each and every record. 1 to 2, 1 to 3, 1 to 4, 1 to 5. If 1 and 2 has the least distance, you cluster those two together. Right? And if 4 and 5 is next closest, you try to cluster those two together. If 3 and 4, 5 are close to each other, you try to cluster that together. In that way, you keep on proceeding with the clustering exercise. All right. All the while you're saying that those two are close to each other, two records close to each other. How do you actually evaluate on which two records are close to each other? That's the problem that we're trying to solve now. So if you were to record or calculate the distance between two records, how do we do that? Even before we get into the calculation of the distance, we need to understand on the distance part. Distance between two records, I and J. Distance between the two records, I and J, is calculated provided these things are borne in mind. First one, distance should be non-negative. Of course, can distance be ever negative? You start from a place and you go to a place. Either you go in the forward direction or backward direction. The distance will always be positive because the start point is this and this is the finish point. Or the start point is this and this is the finish point. So the distance can never be negative. That's the first point that we need to bear in mind. Second, distance of one record from itself is always equal to 0. Third point, distance between A to B, which is Dij, is always equal to distance between J and I. So distance from this point to this point is equal to distance from this point to that point. Also, we have a triangular inequality that we need to bear in mind. That is, if you have 3 points, I, J, and K, distance between I to J plus, this is Dij assume, plus distance between J to K should be always greater than, this should be greater than or equal to Dij. So it should not so happen that the distance between I and K is greater than this distance. So what does that mean? It should not ever so happen that distance between I and K is greater than this. So always distance has to be this or less than that. Less than that meaning if you have a triangle in this way, the distance between this and this should always be greater than the distance between the third side. Assume this is I, J and K. So the distance between Dij and distance between Djk, the distance between these two summation should always be greater than or equal to the distance between Ik. Yeah, these are the 3 rules which any distance formula should abide with and it will abide with.